Okay, in this video I'm going to show you what you need to do in Excel in order to complete lab assignment number 4. Let me point out at the very beginning that while I'm going to show you here what needs to be accomplished in Excel, it's going to be up to you to understand what's going on statistically here. And in order to do that, you might need to review Chapter 4 in your textbook and Chapter 14, Section 1. So let's get started. This is the data set that you've been provided. You see in column B we have the outcome variable, the exam score, and we're going to see whether or not these homework grades predict how someone did on the exam. So I ask you in the first question to simply run some scatter plots around each one of these homework variables. Let me make this a little bit smaller so you can see it all at once. There we go. So to do that, we're going to select the exam score, and then holding down the control key, we'll select homework 1. Now I'm going to go over to the insert menu, click on charts, the scatter plot example, and there you go. To make things a little bit easier, you might want to just label this exam. I use X, exam by HW1, homework 1, and that's our first scattergram. And you'll copy and paste that into a Word document and provide some interpretation. For the next one, again, we'll select exam score. Again, hold down the control key and go over to insert. And this would be exam again by HW2. I'll show you a neat little trick here. You might want to do this. I think it's the best practice. We can get Excel to draw a trend line, a regression line, essentially, through this scattergram by going up to this Add Chart Element trend line, and we're expecting this is a linear trend, so we'll click linear, and that gives us what the regression line would look like just looking at the exam score and homework number 2. All right, so you can continue that with homework number 3 and homework number 4. I'm going to delete these here because I don't really want to look at them right now. Now let's take average homework score. We need to compute that average. So in order to do that, we'll put an equal sign in. We'll type out the word average, which I misspelled, as I often do. And we're going to select all of these homeworks, okay, like that. And that is the average homework score for this person, 98.225. That's pretty good, actually. And interestingly, you'll notice here that this person's score is correlated pretty well with his or her exam score. They did well on the exam, and they did well on the homework. Now, I noticed in class today that a couple of people made the mistake of selecting all of these columns. And if you do that, you're going to not get the average homework score. You're going to get the average of every score. You're going to wind up getting the wrong answer. So let's go up there. When that turns into a little cross, just double click, and it's going to fill down. You could ignore this little arrow here. It's doing that because it thinks it's kind of giving me a warning that that this is coming in as text data, even though it's a number. In our analysis, it's not going to make any difference. If I was upset about it, maybe I could go over here to change it. Well, it still does it. Such are the mysteries of Excel. I'll be real happy if you report everything with 3 decimal places. All right, so anyway, so now let's do our real correlation that we're interested in. And again, I'm going to select everything in exam score, hold down that control key, drag down, select all of the homework values, go up here to charts, create that scattergram, and again, for extra credit, as they say, not really, we'll put a line through that data. And let's give this title, let's give this chart a title, exam by average homework. Okay. By the way, while the scattergrams are good to look at, and this looks to be fairly well correlated, this is a positive correlation, and it looks like a reasonably strong one because the points are not that far away from the trend line or regression line that we've drawn there. So it doesn't look too bad. But another thing that we can do here is we can find out what the actual numerical correlation coefficient is. You'll get this later on. You'll get this later on in your regression analysis, but we can compute it without doing the regression by typing in Pearson. By typing in Pearson, and then putting in the two arrays that we want to correlate, the two data sets that we want to correlate. Again, I'm going to do the same thing I did there before. Notice that little comma in there and the correlation of 0.746. Okay. Okay, so you'll copy this out of the spreadsheet and put it into a nice Word document or whatever word processing software you use. And with this, you should be able to answer questions 1 through 3. All right? Now let's go on to do the regression part of the assignment. Okay. So what we want to do is we want to get the data analysis tool pack up and running here. It should live on the Data tab, but for some reason Excel wants to send it away, wants to send it packing each time I restart Excel. That's what happens in the lab as well. So in order to get that analysis tool pack up here, I need to go over and load it into Excel. I'm going to go to the File menu, click on Options, click over here on Add-ins because it's considered an add-in. Click Go. And in class, for some reason, that other menu doesn't disappear. But if you get rid of it, you just click Analysis Toolpack here. None of these other ones are things you want to worry about. Just the Analysis Toolpack. Click OK. And lo and behold, there's the Data Analysis Toolpack. So I'm going to click on that. And I'm going to scroll down till I find Regression. Click OK, and it's going to present me with this dialog box. Now, unlike correlation, in regression, the order in which you put in the variables is key. If you put the x values into where the y should go and vice versa, you're going to get a line that is predicting x based on y. We don't want to do that. We want to predict y, or the exam score, based on knowing what someone's homework score was. So, making sure that the cursor is in that field. I'm going to do this. I'm going to select here the first row that has the variable label in it. I'm going to fill down. I'm going to now put my cursor in the X input range. Again, this is key. Select down. Don't go too far down here because it won't work. Your regression won't work. If your spreadsheet is set up like mine, you're going to have B1 through B23 and G1 through G23. Now, if I run this the way it is, it's going to throw an error. Why is that? Because it's going to try to do the regression using this as a value, but it's not a value, it's text. So in order to prevent that from happening, I have to tell Excel that my variables have labels. There you go. Okay? And we do want to know what our residuals are. And I don't really want to know what the standardized residuals are, but we want the residual plot. And just for fun, we'll throw in that normal probability plot. That is described in chapter 14, section 1. I'm going to have this generate a new worksheet. Those apply down here. Those will appear down here. Click OK. Ta-da! There we go. Oops. All right, let me look at this one. Well, let's see what happens here. Yeah, it wants to put that in front. I don't know why that is. Well, anyway. All right, so let's first look at the output. Maybe that makes more sense. Remember that R value that we got, that Pearson's R value that we got when we did it manually with that Pearson's command? That Pearson's function, I should say. 0.746, 0.7457, which is going to round to 0.746. Excel in this regression output is calling this multiple R. It's calling that for reasons you don't really have to worry about. That's essentially R. This is R squared. Adjusted R squared is not something we need to worry about in a simple linear regression problem. What we do need to do, though, to answer the rest of the questions is we do need that regression line. So you'll recall that the regression line is given by, or equals, y equals a plus b times x, right? I hope you can see that, okay? So a is the intercept, b is the slope of the regression line. The slope of this line right over here, okay? So you'll write this out as, and I'm going to type it here just because I don't want to open up anything separate there. Sorry, it's going to do that. That is going to be equal to the intercept, which is 0.425. We'll round that out. 0.425 plus the slope of the x value, 0.428, if I round that out, times x. So that is our model. That is our regression line. Okay? Let's take a look at some interesting stuff down here. Okay, and by the way, you're pretty much done with most of what you have to actually do in terms of Excel for this assignment. But let's look a little further. You'll notice, again, Chapter 14, Section 1, you'll understand how to interpret this residual plot. I think I went over this 3 times in class, so hopefully I don't have to do that again. This is showing what we want it to show, and it's important that you understand why it's doing that, because I have a feeling that'll come up again on an exam, because I'm real into this stuff. And you can also read about how to interpret this normal probability plot. Again, Chapter 14, Section 1. Let's just take a look at some other things that are going on here. Let me go over, I did this with some of you guys in class. I'm just going to put some row numbers in here. This is a cute little trick that Excel turns out knows how to count. So let's take a look. So this column over here, you can't really see it because it's cut off. Based on that model that I had up a minute ago, that would be this model right over here. Let me just put it where you can see it. Well, I guess you can see it over there. Okay, based on this model over here, y equals 0.425 plus 0.428 times the x value. Okay, that is telling me that for this guy over here, this person over here, person number 1, okay, what Excel is doing is taking this x value, 0.982, and substituting it into our model, okay, and with the intercept and the slope of the regression line that we have, and it's yielding this prediction for y. So according to the model, this person, whoever he or she is, okay, whatever their homework score was, Excel is saying, gee, this is what we are predicting, this is what I'm predicting this person's exam score will be. Turns out they're a little bit off. They're off by 5 points. Let's take a look at what their actual exam score was. Their actual exam score was 0.89. Actually 0.9 just about, because if we round that out, 0.900. Excel is predicting that their score is going to be 84, and the residual, the error is 5 percentage points. 5 percentage points. Not too bad. Let's find another one. This one over here. Excel is saying here, the regression model, I should say, is saying here that according to this model that we have up here, according to that model, based on this person's homework score, they should have gotten 53 on the exam, or 54, depending on how you decide to do a rounding. Okay? In point of fact, person number 12 got a 53. Got a 53. The model predicted that they'd get about a 54, actually even less than 54, 53.7 essentially. So this has a very small residual. In this case, the model did a very good job of predicting how this person would do. Okay, let's take a look at person 17 here. Okay, the model predicted that based on their homework score, they would get a 73 on the exam. What did they actually get? The person actually got a 94. The person actually got a 94. So the prediction error was a pretty substantial one, 20 points. 20 points. This person, I would guess, I don't know, I would guess this person did really, is pretty diligent and did all these homeworks. For some reason, I don't have a Chapter 4 homework grade for that person. My guess is they did it, they didn't submit it, or something. But this is a person who knows his or her statistics, but for some reason, I don't have a grade here for homework 4, so the model is predicting that the person actually is going to do a lot worse than, in fact, they wound up doing. So the thing to think about, I think it'd actually be kind of interesting for you to take a look at what your exam score is on this sheet. Find yourself on this sheet, sheet 1, and then find out what Excel predicts. And try to think why Excel is right or why Excel is wrong. There are lots of possible reasons for differences between what a model predicts and what actually is happening in the real world. And we went over a number of them in class. I'm not going to review that here again. So hopefully this makes this stuff pretty clear. Again, that's how you run this in Excel. And how do you interpret all this stuff and make sense of it, you'll get from your notes, from what we've discussed in class, and from Chapter 4 and Chapter 14, Section 1. Don't forget to email it to me at egraig@york.cuny.edu, and you have until Monday at midnight to send this in to me. Have a pleasant weekend.